Now let's see CLR example. Construct CLR parse table for the following grammar. S produces CC, C produces CC or T, and parse the input string DD. Okay. So now let us solve this problem. CLR stands for Canonical LR Parser. L stands for we are scanning the input from left to right. R stands for rightmost derivation in reverse order. The major difference between SLR and CLR is in SLR parser we will calculate LR of 0 items, whereas in CLR parser we calculate LR of 1 items. LR of 1 item is nothing but LR of 0 plus look ahead symbol. Look ahead symbol. So if we add look ahead symbol to LR of 0 item, then we will get LR of 1 items. So here also we need to follow the same steps. Step 1 is finding augmented grammar. Step 2 is instead of calculating LR of 0 items, here we calculate LR of 1 items. Next step is construction of the parse table, and the next step is parsing the input string. We know in order to derive the input string, we start from start symbol. So here what is the start symbol? S is the start symbol. So S produces CC. So here the minimum possible input string is C produces D here. So C produces D, C produces D. So the minimum possible input string that we can derive from this grammar is DD. So let us parse the input string DD. The parsing of the input string in CLR is also similar to SLR. So there is no difference in parsing. Okay. So now let us. So here the first production is S produces CC. Next one, C produces small c, capital C. Next one, C produces small d. So this is the grammar that we given in the problem. Now let's see the first step. Here the first step is finding augmented grammar. So write the augmented grammar. Augmented grammar. So in order to write the augmented grammar, we have to write an extra production called start symbol dash produces start symbol. Here the start symbol is yes. So here the augmented production is S dash produces yes. And then write the remaining productions of the grammar as it is. The first production is S produces CC. Next one is C produces small c, capital C. Next one is C produces D. So this is step 1, writing the augmented grammar. Now let's write the step 2. Here step 2 is calculating LR of 1 items. Calculating LR of 1 items. Whereas in SLR parser we calculate LR of 0 items. Whereas in CLR parser we will calculate LR of 1 items. We know what is item. Item means there is a dot symbol at right side of the production. So the first production can be written as S dash produces. This is an item. So dot should be at beginning of the right side. Dot S comma. Here we need to add look ahead symbol. Then only we will get LR of 1 item. For the augmented production, for the initial production, the look ahead symbol is dollar symbol. Okay. So for the augmented grammar, we have to write dollar as the look ahead symbol. Next here, after dot, we have a non-terminal. If there is a non-terminal after the dot symbol, then we have to write the productions of the non-terminal. So what are the productions of the non-terminal? Here we have one production. S produces CC. But it is an item. So there is a dot symbol at beginning of the right side. So dot CC. Next we have to write the look ahead symbol. So in order to write the here calculation of look ahead part is very simple. S dash produces dot S comma dollar is nothing but the production. Here after dot we have S. So that's why the production of S is written. Here we need to calculate first of the remaining part. Here after S there is no symbol, so this can be written as dot S into epsilon, because anything into epsilon is nothing but anything only, comma dollar. So S produces, so this is nothing but concatenation operation. So we have to calculate first of this part. So first of epsilon into dollar. So first of epsilon into dollar is nothing but first of dollar. So the look ahead part is dollar here. So very simple here. Okay, we need to calculate first of the remaining part after the corresponding non-terminal. Here after S there is no symbol. So first of epsilon into dollar. So epsilon into dollar means dollar. So first of dollar means dollar. So dollar is nothing but, so first of dollar means dollar. So dollar is the look ahead part here. Next here, after dot we have a non-terminal called C. So we need to write the productions of C. What are the productions of C? C produces, this is an item, so dot should present at beginning of the right side. So dot CC. Next one, C produces dot D. Next we have to calculate the look ahead part. So here what is the production? S produces dot CC comma dollar. So the C productions are written because after dot we have this C. So we need to calculate first of this part because this C production is written. C produces dot C, C produces D. Okay. So first of C dollar. So what is first of C? Here first of C. C is producing two productions. So first of C dollar. So this can be written as first of C into dollar. So first of C dollar is nothing but first of C. So what is first of C? Here C is producing two productions. The first production is small c capital C. So first of C is nothing but this small c. So first of C is nothing but this small d. So first of C is nothing but C or D. So look ahead symbols are C or D. Okay. So very simple here. In order to calculate the look ahead part, what we are doing here, this is the production. S produces dot CC or dollar. Here after dot we have this C. So we need to write the productions of C. So the productions of C are written. C produces CC, C produces dot CC, C produces dot D. Next we have to calculate the look ahead part. In order to calculate the look ahead part, we need to calculate first of this remaining part. So the C productions are written. So the remaining part is first of C dollar. So first of C into dollar is nothing but first of C. So what is first of C? This production is beginning with small c. This production is beginning with D. So first of C is nothing but C or D. So this is nothing but look ahead part. So all the productions are written. So this is nothing but the state, the starting state. Let us assume that the starting state is I naught. So this is nothing but I naught state. Okay. And next we have to calculate the remaining states. So what are the possible inputs that we can apply on I naught state? After dot we have S. So we can apply S on I naught. We can apply C on I naught. We can apply small c on I naught. We can apply small d on I naught. So let us calculate the first one. Go to of I naught comma. So here after dot we have S. So go to of I naught comma S. So apply S on I naught. Whenever we apply go to, then dot will be moved one position to the right and write the look ahead symbol as it is. So whenever we apply go to on this production, then what will happen? S dash produces. Here dot will be moved one position to the right. So this production will become S dash produces S dot comma. We need to write the look ahead symbol as it is here. Here after dot there is no non-terminal. So there is no need of any expansion. So go to of I naught comma S is over. Let us assume the state as I1. Next, what is the next input that we can apply on I naught? Here after dot we have capital C. So go to of I naught comma capital C. There is only one production which contains capital C after the dot. Only this production. So apply go to on this production. Whenever we apply go to, then dot will be moved one position to the right. So the production will become S produces C dot C. So S produces C dot C. And we need to write the look ahead symbol as it is. Here what is the look ahead part? Dollar. So we need to write the look ahead part as it is. And then here after dot we have a non-terminal. So we need to write the productions of C. So what are the productions of C? C produces, this is an item. So there is a dot symbol at beginning of the right side. So yes, C produces dot CC. Next C produces dot D. Next we have to write the look ahead part. In order to write the look ahead part, we need to calculate first of this part. Here this C productions are written. So what is this production? S produces C dot C comma dollar. After dot we have C. So that's why C productions are written. So we need to calculate first of this remaining part. Here after C we don't have any production. So let us assume this one as epsilon. So first of epsilon into dollar. First of dollar. So first of dollar is nothing but dollar. So this is nothing but dollar. Look ahead part. So I1 is over. Let us assume this state as I2. So next one, go to off I0 comma. Here after dot we have small c. So apply small c on I0. So whenever we apply go to, then dot will be shifted one position to the right. So this production will become, dot will be moved one position to the right. So small c dot capital C comma. Whenever we apply go to, then we need to write the look ahead part as it is. Here what are the look ahead symbol? C or D. So C or D is nothing but look ahead symbol. So this is nothing but production, comma this is nothing but look ahead part. Dot S is the production, dollar is the look ahead part. Dot CC is the production, dollar is the look ahead part. Dot CC is the production, CRD is the look ahead part. So S produces C dot C comma. We need to write look ahead part as it is. Here after dot we have a non-terminal called capital C. So we need to write the productions of C. So the productions of C are C produces dot CC, C produces dot D. Here this is nothing but C non-terminal. So here how to calculate the look ahead part? So first of this remaining part. Here we don't have any symbol after C. So let us assume this one as epsilon. So first of epsilon into C by D means first of C by D. So first of C by D means C by D. So I0 comma C is over. Let us consider this state as I3. So next one, go to off I0 comma. So what is the input that we can apply? After dot here we have small d. So whenever we apply go to, then what will happen? Dot will be shifted one position to the right. C produces D dot comma. We need to write the look ahead part as it is. So small c or D. So go to of I0 comma D is also over. Let us consider this state as I4. So all the inputs are applied on I0. Now let us consider I1. Here after dot there is no symbol. So there is no need to apply go to on this production. Next if we consider I2, after dot we have capital C, small c and D. So we need to apply capital C, small c and small d on I2. So go to off I2 comma. Here after dot we have capital C. So apply capital C. Okay. So whenever we apply go to, then what will happen? Dot will be moved one position to the right. So the production will become S produces CC dot, and we need to write the look ahead part as it is. So S produces CC dot, and we need to write the look ahead part as it is, comma dollar. Here after dot there is no non-terminal. So no need of any expansion. So go to of I2 comma C is over. Let us consider this state as I4 is over. So the next one is I5. So next one, apply small c on I2. So go to off I2 comma small c. So whenever we apply go to, then what will happen? Dot will be moved one position to the right. So this production will become C produces small c dot capital C, and we need to write the look ahead part as it is. So C produces small c dot capital C, and write the look ahead part dollar as it is. Here after dot we have a non-terminal. So we need to write the productions of C. So the productions of C are C produces dot C capital C, C produces dot D. And we need to write the look ahead part. Okay. Here after C we don't have any symbol. So let us consider this one as epsilon. Epsilon into dollar means dollar. So first of dollar means dollar. So what is this state now? If we consider I3, C produces C dot C, C produces dot CC, C produces dot D. Productions are same, but in I3, what are the look ahead symbols? The look ahead symbols are CRD, CRD, CRD. whereas here the locate symbols are dollar, dollar, dollar. So locate symbols are different here. So we should not give I3 as the state here. Why? Because the productions are same, but the locate symbols are different. So we have to give a new name for this state. I5 is over, so I6. If the locate symbols are also same, then we should give the state name here. So next we have to apply small d on I2. So go to of I2 comma d. So whenever we apply go to, then dot will be moved one position to the right. So the production will become C produces D dot comma. We have to write the locate part as it is. So if we consider I4 and this production, in I4 the locate part is C by D, whereas here the locate part is dollar. So locate symbols are entirely different. So we should not give I4 as the state name because locate parts are different. So let us consider the next one as I6 is over. So I7. So next one, all the productions of I2 are processed. And next we have to process I3 productions. Here after dot we have capital C, small c and small d. So we can apply these three inputs on I3. So go to of I3 comma capital C. So if we apply go to, then what will happen? Dot will be moved one position to the right. So C produces C dot comma. We have to write the locate part as it is. So CRT. Here after dot there is no symbol. Okay. So there is no need of any expansion. So we have to check whether this production is available in any state or not. So this is not available in any state. So let us consider this one as I7 is over. So I8. Next one go to of I3 comma capital C is over. So small c. So C produces. So whenever we apply go to, then dot will be moved one position to the right. So C dot C comma CRT. CRT. So this one is nothing but same production. Here after dot we have C. So we need to write the productions of C. So C produces dot CC. C produces dot D. So what is the locate part? First of this part. That is nothing but CRT. So this one is nothing but I3 only. Okay. Because here productions are same as well as locate symbols are same. So if productions are same as well as locate symbols are same, then only we have to give that state name. Here we have three productions. Productions are same as well as locate symbols are same. So what is the production number here? I3 is nothing but the state name. So go to of I3 comma small c is over. Next we have to calculate go to of I3 comma D. So whenever we apply go to, then what will happen? A dot will be moved one position to the right. So C produces D dot comma. What is the locate part? CRD. So C produces D dot CRD. So C produces D dot CRD. So production is same as well as locate part is same. So this is nothing but the state number I4. So all the productions of I3 are processed. Next we have to process I4. Here after that there is no symbol. So no need to calculate go to on this production. Next if we consider I5 also, after dot there is no symbol. So no need to calculate go to on this production. If we consider I6, after dot we have capital C, small c and D. So we need to apply these three inputs on I6. So first one go to of I6 comma capital C. So whenever we apply go to, then dot will be shifted one position to the right. So the production will become C produces CC dot comma what is the locate part? Dollar. So we need to write that part as it is. Okay. So we have to check whether this is available or not. If we consider I8, here the locate part is C or D, whereas here the locate part is dollar. So they are different. So we have to give new name for this state, I9. Next one go to of I6 comma small c. I6 comma small c. So the production will become C produces C dot C comma dollar. Because dot will be shifted one position to the right. What is the locate part? Dollar is the locate part. Next write the productions of C. C produces dot CC. C produces dot D. we have to calculate first of this part. So this is nothing but dollar only. This is nothing but dollar only. So C produces C dot C, C produces dot C, C produces dot D. So same number of states, same productions, here same productions as well as the same locate symbol. So this one is nothing but the state I6. Next let us apply small d. So if you apply small d on this production, then what will happen? C produces d dot comma dollar. So C produces d dot. C produces d dot comma dollar. Yeah, so this one is nothing but I7 only. Same production as well as same locate part. I7 only. So all the productions of I6 are processed. Next in I7 after dot there is no symbol. In I8 also after dot there is no symbol. I3 already processed. I4 already processed. I9 after dot there is no symbol. I6 already applied. I7 already applied. So this is nothing but calculation of LR of 1 items. Next we have to construct CLR. So next the construction of CLR parse table. Construction of CLR parse table. So in order to construct the CLR parse table, we have to take the state names. Here we have 10 states from 0 to 9. So 0 state, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally we have 10 states from 0 to 9. So write those states. So next it contains two parts. The first part is action part. So this is nothing but CLR parse table construction. First part is action part. The second part is go to part. Go to part. The action part is nothing but terminal symbols. So what are the terminal symbols present in the grammar? C, D as well as dollar. So C, D as well as dollar. Next go to part is nothing but non-terminals. The non-terminals of the grammar are capital S, C. Capital S, C. So next. So what is the first one here? First go to here. 0 S. 0 S means 1. So if we apply S on 0, then we will get state number 1. So 0 is nothing but I0 is nothing but 0. I1 is nothing but 1 here. So 0 S means 1. So 0 S means 1. Next 0 C means 2. So 0 C means 2. Next one 0 small c means 3. If it is a terminal symbol, then we have to perform shift operation. Here terminal symbols are small c. This is nothing but small c. Small c, small d are nothing but terminal symbols. So whenever the input is terminal symbol, then we have to perform shift operation. Shift operation is denoted with S. So 0C means S3, where S denotes shift. Next 0D. D is a terminal symbol. If it is a terminal symbol, then we have to perform shift operation. So 0D means S4. Next one 2C. So this is nothing but capital C. So 2 capital C means 5. 2 capital C means 5. Okay. So next one 2 small c means 6. C, it is a terminal symbol. So we have to perform shift operation. So 2 small c means S6. Next one 2 small d, it is a terminal symbol. So shift operation. Next 3 capital C means 8. 3 capital C means 8. 3 small c means 3 only. So 3 small c means shift operation. S3. 3 small d means shift operation. S4. 6 capital C means 9. 6 capital C means 9. Next 6 small c means 6. It is a small letter, that is nothing but terminal symbol. So 6 small c means S6. So 6 S6. 6 small d, it is a terminal symbol. So 6D means S7. So this is nothing but shifting operation. Next we have to write the reduce operations. In order to write the reduce operations, first we have to give some names for the productions. So this is nothing but zero production, because this is the extra production that we have added. So what are the productions given in the grammar? This one, 1, 2, 3 is nothing but the productions which are given in the grammar. In order to write the reduced productions, we have to check where the final items are. Final item means dot should present at right end of the production. Dot should present at end of the production. So here the final items are S dash produces S dot, S produces CC dot, C produces CC dot, C produces D dot. So dot should present at end of the production. So in I0 we don't have any final items. If we consider I1, S dash produces S dot, it is a final item. It is a final item because dot is available at end of the production. So $1 means here S dash produces S is nothing but the production 0. Okay, so here $1 means here this is nothing but augmented production, extra production which is added to the grammar. So $1 means it is always accepted state. So what is the state number? 1 is the state number. Look at part is dollar. So $1 means accepted. In SLR or CLR or LR, $1 always provides accepted grammar. Why? Because S dash produces S is nothing but an extra production which is added to the grammar in order to parse the input string. Next, if we consider I2, there are no final items. If we consider I3 also, no final items. If we consider I4, we have a final item. So 4, what is the look at part? So 4 CD. So what is the production number? C produces D is nothing but 3. So R3, because we need to perform reduce operation here. R3. So we have to add R3 at 4C and 4D part. 4C and 4D part. So this is the difference between SLR and CLR part. In SLR part, we need to calculate follow of this left hand side non-terminal. Follow of C. Follow of C produces some terminal symbols. In those terminal symbols, we have to write the reduced productions. Whereas here, already lookahead symbols are available in the production only. So there is no need to calculate follow of the left hand side non-terminal. So 4 CD means, so C produces D is nothing but the production number 3. So 4 CD means R3, R3. Next, let us consider I5. I5 also contains final item. So C produces CC dot. So $5. So in $5 part, which reduced production we have to add? S produces CC is nothing but first production. So $5 means R1. $5 means R1. Next one, I6. In I6 we don't have any final items. I7 we have a final item. So $7 means in $7 we have to add C produces D is nothing but 3. So in $7 we have to add R3. Next one, C produces CC dot. This is nothing but final item only. So 8 CD. So 8C and 8D. So what is the production number? 2 is the production number. So 8 CD R2. R2. Why? Because C produces CC is nothing but production number 2. Next one, in I3 we don't have any final items. I4 we don't have any, I4. This is a final item, but already it is processed. Already R3 and R3 are already written. Next, if we consider I9, we have a final item here. So $9 means, what is the production number? C produces CC. So R2. So $9 means R2. So I6 already processed, I7 already processed. So this is nothing but CLR parse table construction. Now let us parse an input string with the help of this parse. So now parse the input string. Here we have 3 columns. The first column is tag. The second column is input string. Third column is action. Which action we are performing? Shift action or reduce action. Bottom of the stack contains $. Let the input string is DD. End of the input string contains $. Initially 0 is pushed onto the top of the stack. So 0 is nothing but stack's topmost symbol. D is nothing but current input symbol. So 0D means, what is 0D? S4. So shift 4. While performing the shifting, first we have to shift input symbol. So what is the input symbol? D. Next shift state number. Here the state number is 4. So D is shifted onto the top of the stack. So the remaining input string is D dollar. So 4D. So what is 4D? R3. So reduce. What is the third state? Third production. C produces D. Here the right hand side contains one symbol. If the right hand side contains only one symbol, then we have to pop two symbols from the stack. Why? Because while shifting also we are shifting two symbols. Current input symbol as well as state number. So likewise while performing popping also we need to pop two symbols if the production right hand side contains only one symbol. Whereas if the production right hand side contains two symbols, then we have to pop 2 into 2. That is nothing but 4 symbols from the stack. Here the parsing of the input string is similar to SLR input string parsing. Both are same only. There is no difference. Okay. So dollar. So we have to pop 4 as well as D. So if you pop 4 and D, then the stack's topmost symbol contains 0. So 0, left hand side non-terminal is C. So 0C means C2. So first we have to shift C in symbol, next shift state number. So 0C2, next D dollar. So 2D. So 2D means S7. Shift 7. So while performing the shifting, first we have to shift the input symbol, next shift state number. So D is shifted onto the top of the stack. So the remaining input string is dollar. So $7. So $7 means R3. So what is R3? C produces D. Right hand side contains one symbol. So we have to pop stack's topmost two symbols. So $0C2 because 7 and D are popped. So 2 is nothing but stack's topmost symbol. Whereas here the left hand side non-terminal is C. So 2 capital C means C5. So first shift the symbol. Next shift state number. So 2C means what? C5. Next dollar. $5. So what is $5? R1. So what is R1? S produces CC. Here the right hand side contains two symbols. If the right hand side contains two symbols, then we have to pop 2 into 2. That is nothing but 4 symbols from the stack. So 1, 2, 3, 4. So these 4 are popped. So $0. So 0. Left hand side non-terminal yes. So 0S means S1. So first shift the symbol, next shift state number. So $1 means accepted. So we can say that this input string is accepted by the grammar. So this is about CLR parse table construction as well as parsing of the input string using CLR parse table.